Hi, Chapter 8 deals with analyzing units. Now, analyzing units is when we're converting from one unit to another, such as miles per hour to feet per second. Alright, so here are the steps to it, and then we'll just go through a whole bunch of examples. First, you want to label and write down everything that you know, including the units. Don't ever lose anything. Okay? Make a road map of your starting point and your ending point. I'll show you how to do that. You're going to write down each conversion, and what you're going to end up doing is you're going to be multiplying and canceling stuff out. Okay? Those are our steps. So let's first talk about what a ratio is. A ratio involves a comparison of two numbers written as a fraction. Okay, so if I'm talking about 60 miles per hour, we actually write it like this: 60 miles per 1 hour. That's what we usually write. Okay, let's talk about an example of how this is useful. So if I have a 12-ounce can of refried beans and it sells for 59 cents, and I have a 16-ounce can for 81 cents, which can be the better buy? So these are called unit pricing. We're trying to figure out how much am I going to spend for each ounce. Now I could simply just take 59 divided by 12 and that would tell me how much I'm spending for 1 ounce. But let's just write that out. So I can write a ratio saying, hey, it's going to cost me 59 cents per or for 12 ounces. Or I could choose to spend 81 cents for 16 ounces. Now remember, when we have fractions like this, a fraction bar is simply a division problem. So all I'm going to do is divide. So if I take 59 divided by 12, and I did that on the calculator, I get 4.9. What does that mean? That means that it's going to cost 4.9 cents per 1 ounce. And that's how we're going to write it today. If I take 81 divided by 16, I get 5.1 cents for 1 ounce. So in all reality, when we break it down like that, we can simply see that it's cheaper to buy 12-ounce can for 59 cents. Okay. Now, that's unit pricing. Let's do something with what's called unit conversion. Unit conversion is where we use products of ratios to get the correct conversion. So you're going to go to page 502 to see some of the common conversions. A product means that we're going to be multiplying, so we're going to multiply. And a ratio, remember, is fractions, so we're going to multiply fractions together. Alright, another thing you need to know, whenever you see the word per, that means to do a division problem. So if a car travels at a rate of 55 miles per hour, we could think of it as 55 miles per hour. Now, here's something that you need to know. It's pretty important. You can also flip those things around. You can write 1 hour over 55 minutes. It doesn't matter, okay? Because you're going to be able to, allowing us to flip a fraction like that is going to be really, really important when we do our multiplying, okay? And it's going to show up in this problem. So here is my very first problem. A car traveling at 65 miles per hour gets 25 miles per gallon and travels for 45 minutes. How many gallons does the car use during that time? There's a lot of stuff going on. So let's just break it up and write everything down first. I have 65 miles per hour. So I'm going to write my ratio of 65 miles, don't forget your units, per 1 hour. Now remember, you could flip that around if you wanted to and write it as, in 1 hour, I'm going to go 65 miles. It doesn't matter, okay? Just I want you to keep that in mind, that those things are exactly the same. We just flip them around a little bit. Okay? All right, let's look at another one. We got 25 miles per gallon. All right, so my other ratio that we're talking about is we're going 25 miles per 1 gallon of gas. What else do we have? We're going to travel for 45 minutes. So we're going to travel 45 minutes. And the question is, how many gallons does the car use? So, how many gallons? And that's the question. All right. So, in our steps, it says write everything down. So we did. Then what we want to do is we want to kind of write a road map of our starting point to our ending point. So here's my road map. I'm going to start. I'm going to go somewhere. All right. What do I want to get to? Usually the question is going to help us with that. I want to get to gallons. Now, where did I start? Well, I started at traveling 45 minutes. That's where I started. That's what I know. So I'm traveling 45 minutes. So I don't have any way to go from minutes to gallons, but if I look at this conversion right here, I can get from miles to gallons. So miles. Okay. Well, I can't get from minutes to miles, but if I look at my conversion here, I could get from hours to miles. Okay. Now I have a problem. I need to get from minutes to hours. Do I know a conversion from minutes to hours? I do, actually. I can go 60 minutes in 1 hour. So I have this conversion right here. Okay, so let's see what this looks like. Let's start out with 45 minutes. And I'm going to put that over 1 because that's going to be a fraction. Times, we're going to use our changing it to hours. So we're going to use 60 minutes per hour. But remember, I can flip things around. So I'm going to have 1 hour over 60 minutes. Why did I flip that around? Well, when we multiply fractions, we can cross cancel. Anything that's on the top will cancel out with what's on the bottom. And so I needed the minutes to cancel out. And so that's why I put the minutes on the bottom and the hours on top. Okay, so we use that one. Now we want to get to miles. The relationship between hours and miles is right here, 65 miles per hour. Why did I choose that one? It's because I needed the hours on the bottom. So we're going to take it times 65 miles per 1 hour. And I can see that the hours cancel out. So now I'm at miles. Now, what ratio am I going to use to get to gallons? I'm going to use 25 miles per gallon. Now I'm going to have to flip that around because I need the miles on the bottom. So 25 miles, 1 gallon. I can see that the miles cancel out. And so now I have gallons left on the top. So I take 45 times 65, divide it by 60, divide it by 25, and I get 1.95 gallons as my answer. Okay, so now let's move on to the next type of problem, which deals with what we call count pound units. That's where we combine units together to get a desired answer. So here's 2 different examples. We have what's called a passenger mile and a student hour. So the unit passenger miles is the product of the number of passengers and the number of miles the passengers have been carried. Okay, so if there's 200 people on an airplane that travels 1,000 miles, what is the number of passenger miles? So we simply take 200 times 1,000 and we get 200,000 passenger miles. And that's it. That's all it's to it. Same here goes with student hours. The unit student hours is the product of the number of students in a section and the number of credit hours in a course. So if I have 15 students, 3 credit hours, we basically take 15 times 3 and we get 45 student hours. Okay. Another type of compound unit is dealing with area and volume. Okay. Now suppose we have this rectangle and it's 864 square inches. Let me draw this rectangle really quick so we can explain it of why it's a compound unit. So 864 inches squared. Now let's just pretend that I know the lengths of the sides. Let's pretend that this is 24 inches and this is 36 inches. When I multiply them together, I get 864. But basically what you're doing is you would take 24 inches times 36 inches to get 864 square inches. Now let's rearrange this a little bit. Let's say we have 24 times 36 times inches times inches. Well, then that gives us 864 inches times inches. And what I wanted you to notice here as this is our compound unit. Inches squared is the same as inches times inches. Okay, that's going to come in very handy because if I want to convert 864 square inches to square feet, the only thing I know about inches and feet is I know that there's 12 inches in 1 foot. That's all I know. So let's rewrite my 864 square inches as inches times inches. And let's just put that over 1. That is my first fraction. I know that there's 12 inches in a foot, so I'm going to have to flip this around. So I have 1 foot is equal to 12 inches. Now, why did I write square inches as inches times inches? It's because of this. If I cancel, I can only cancel one out at a time. I can't cancel out both. So this means that I have to do this whole process one more time. And so now the inches will cancel out twice. I take 864 divided by 12, I divide it by 12, and I get 6 feet times feet, which is the same as 6 square feet. Okay, and that's how we deal with compound units. So what you can do is you can stop with this video, or you can move on to the next 2 examples, which are a little bit more complicated in the next videos. Thank you.